By the end of this video, my goal is to have you feeling so much more confident, comfortable, and just energized to working with unit vectors so that you can get ahead in your physics career. And if we haven't met before, my name is Mariano, and this channel is all about just sharing the often overlooked details in physics so that we as a whole can have a better understanding of the world that we live in. And we also like anime here. So just tell me in the comments down below, what are you watching right now? Who are your favorite characters? For example, I'm currently watching One Piece and I'm really loving Nico Robin. But now let's get into the video. And as you can see, I've started off here with our axes and 3 examples of unit vectors as well as the definitions. So let's go through this step by step. So these vectors are unit vectors. Now you can tell it's a unit vector because they have that little caret on top, the little hat on top. And that lets you know, okay, you're going to be working with the unit vector here. And our definition for unit vector is simply a vector that we have defined their magnitude to be 1, and which we have set to point in a specific direction. So let me show you what that looks like. On our unit axis here, let's say we have this vector, this, and we have it here, and we have it here. Again, these are unit vectors. Their magnitudes are 1, and they just point in one direction. In this case, the x hat points in the x direction, y hat points in the y direction, and z hat points in the z direction. However, you will see a different notation commonly used in advanced physics, and that is I, J, and K. Now, I, J, and K are equivalent to saying x, y, and z. The I hat vectors points in the x direction, the J hat vector points in the y direction, and the K hat vector points in the z direction. This is just notation that you should start to get to use right now because it's going to be the one that's used in advanced physics. Now, let me tell you the most important insight about unit vectors, and that is the following. A unit vector is simply something that orients us in space. Its sole purpose is to give us direction. For example, I mentioned earlier that I watch One Piece, and in One Piece, it's all about a group of pirates who travel the seas together and they go on adventures. But as you know, when you're on a ship sailing the oceans, you need a compass, and the compass points north, east, south, west. You can think of unit vectors to serve the same role as a compass. They're simply there to guide, to point, to orient you in space and time. Similarly, a lot of people use their faith as a guidance for how they should live their life or how they should behave, the values they should uphold, values to be compassionate, to serve thy neighbor, to be of service to other people. Things like that. Those are the same as unit vectors. They serve simply to guide. And what's truly magical about unit vectors is that they allow us to define any vector in terms of its 3 components in space. For example, you see here ax times I hat, ay times j hat, and az times k hat. This pretty much decomposes the vector into its 3 dimensions, and it has its magnitudes with each dimension in space. Now, I don't want you to take this lightly. Don't sleep on this, because now we have a way to describe forces in 3D space. We have a way to describe velocities in 3D space, and we have a way to describe displacements in 3D space. Anything that's a vector, we now have a really convenient way to describe it in 3D space. And let me tell you, that is going to be a very, very powerful tool that you use throughout your entire physics career. Now, I promised to make this video extremely valuable for you, so let me give you a pro level insight. And that is that you can convert any vector, let's say we have a vector v, we can convert this into a unit vector by dividing by its magnitude. And I want you to think about why that works. Why does that work? Because remember, a unit vector we define to have a magnitude equal to 1. Therefore, when we divide any normal vector by its magnitude, we now have a vector whose magnitude is equal to 1. Now, you should be thinking, okay, well, don't we also need unit vectors to point in a specific direction? And you're right, we do. So now we have a unit vector that points in the direction of this general vector. So because of this, we can pretty much define a unit vector whenever we want and wherever we want. And now this is going to become extremely valuable when you start working in upper level mathematics like linear algebra, and you'll also see it in exams in your physics career as well. So if you learned something in this video, drop a comment down below sharing what you learned, because what you say could be exactly what another student needs to hear in order for them to truly understand the subject. And that's pretty much what we're all about here, just sharing knowledge so that we as a whole can get better. And just let me know, what animes are you watching right now? Do you have any recommendations? I'm looking for more romance animes. I just finished Sign of Affection, and I honestly really liked it.